Today we're going to be talking about the derivatives of trig functions. So here are the derivatives of the trig functions. It'd be great to memorize these for the tests. They can be derived, but you don't have time on tests, so make sure to memorize them. Here's the proof that the derivative of sine of x is equal to cosine of x. And the proof that the derivative of cosine of x is equal to negative sine of x is very similar to this. And then the other trig functions are proved using quotient rule, and I'll show a proof of one of those after this. So using the definition of a derivative, the derivative of sine of x is equal to the limit as h approaches 0 of sine of x plus h minus sine of x over h. Then using the sine double angle formula, which is sine of a plus b equals sine of a cosine of b plus cosine of a sine of b, you get that the derivative of sine of x is equal to the limit as h approaches 0 of sine of x cosine of h plus cosine of x sine of h minus sine of x over h, which can be rewritten as the derivative of sine of x equals the limit as h approaches 0 of cosine of x times sine of h plus sine of x cosine of h minus sine of x over h, which helps factor. By factoring negative sine x out of the two rightmost terms, you get that the derivative of sine of x equals the limit as h approaches 0 of cosine x times sine of h minus sine of x times, in parentheses, 1 minus cosine of h over h. By separating the function, you get that the derivative of sine of x equals the limit as h approaches 0 of cosine of x times sine of h over h minus the limit as h goes to 0 of sine of x times, in parentheses, 1 minus cosine of h over h. Because we are only concerned with the limit of h, the equation can be rewritten as the derivative of sine of x equals cosine of x times the limit as h approaches 0 of sine h over h minus sine of x times the limit as h approaches 0 of 1 minus cosine h over h. You know that the limit as h approaches 0 of sine of h over h equals 1, and the limit as h approaches 0 of 1 minus cosine h over h equals 0. And this can be shown via L'Hopital's rule, but that requires the knowledge that the derivative of sine of x equals cosine of x, which we're proving right now, which would make a circular argument. And the proof can also be shown via squeeze theorem, which is shown on page 190 in the textbook. So this gives us the derivative of sine of x equals cosine of x times 1 minus sine of x times 0, which equals cosine of x. So therefore the derivative of sine of x is equal to cosine of x. Here's the proof that the derivative of tangent of x is equal to secant squared of x. And the proofs for cotangent, secant, and cosecant are also proved using quotient rule. So once you know one of them, it's pretty easy to find the rest. So the derivative of tangent of x equals the derivative of sine x over x. And using quotient rule, we get that the derivative of tangent of x is equal to cosine of x times the derivative of sine of x, which is also cosine of x, minus sine of x times the derivative of cosine of x, which is negative sine of x, over cosine of x times cosine of x. And a little disclaimer is that my equation editor doesn't let me write exponents, so everything in the fractions will be written as cosine of x times cosine of x instead of cosine squared of x. And this simplifies to the derivative of tangent of x is equal to cosine squared of x plus sine squared of x over cosine squared of x. And we know that cosine squared of x plus sine squared of x is equal to 1. So this makes the derivative of tangent of x equal to 1 over cosine squared of x. And 1 over cosine squared of x is equal to secant squared of x. So therefore the derivative of tangent of x is equal to secant squared of x. Here's a sample problem where to find the derivative of the function, we would need to use the derivative of trig functions. So find the derivative of f of x when f of x is equal to x to the 5 times tangent of x. So then using the product rule, we get f prime of x equals x to the 5 times tangent of x prime plus x5 prime times tangent of x. So then we know that the derivative of tangent x is secant squared x, and the derivative of x to the 5 is 5x to the 4. So then we get f prime of x equals x to the 5 times secant squared x plus 5x to the 4 times tangent of x, which can be simplified to f prime of x equals x to the 4 times x times secant squared x plus 5 times tangent x. So that's a good problem where we have to use the derivatives of trig functions. Here's a good problem where to find f prime of x, or the derivative, you need good knowledge of the derivatives of trig functions. So find f prime of x when f of x is equal to sine of 2x plus cosine squared of x. Using the chain rule, we get f prime of x is equal to the derivative of sine of 2x, which is cosine of 2x, times the derivative of 2x, which is 2, plus the derivative of cosine x squared, which is 2 cosine x, times the derivative of cosine x, which is negative sine x. This gives us 2 cosine of 2x minus 2 cosine of x sine of x, which it can be simplified to 2 in parentheses cosine 2 of x minus cosine of x times sine of x. So a common mistake here is when people take the derivative of sine of 2x, they forget about the 2x, making their derivative cosine of x times 2 instead of cosine of 2x times 2. Speaking of common mistakes, here are some more common mistakes people do when taking the derivatives of trig functions or doing problems involving the derivatives of trig functions. So when finding the derivative of something like sine of 3x, people often forget to do chain rule and write the derivative as cosine of 3x rather than cosine of 3x times 3, because you need to also find the derivative of 3x, which is 3. Also, when taking the derivative of something like sine squared of x, people often just take the derivative of sine and square it, getting cosine squared of x, instead of the proper answer, which can be attained through chain rule, which is 2 sine of x times cosine x, because you take the derivative of sine of x squared, which is 2 sine of x, then you take the times the derivative of sine of x, which is cosine of x. The answer can also be obtained through product rule by finding the derivative of sine of x times sine of x. Here are some useful tips and tricks when finding the derivatives of trig functions or doing questions involving the derivatives of trig functions. So when taking the derivative of trig functions, all the derivatives of cofunctions are negative. So the derivative of cosine x is negative sine x, the derivative of cotangent x equals negative cosecant squared of x, and the derivative of cosecant x equals negative cosecant x cotangent x. And so because we know this, then all the other functions, or the derivatives of all the other functions, are positive. Another good tip is when you see something like cosecant squared of x, remember that it can be written as cosecant of x squared, which makes it easier to take the chain rule. And that's the end of my video. Thanks for watching.